Okay, so we're going to get started. We are going to start the MAT1033 final exam review. And I'm going to do my review based on my online intermediate algebra class, but the topics are all the same. Due to time, we may not have time to go over every single problem, but I'm going to try to focus on the ones that I'm pretty sure that people probably have the most difficulty with. I'll also try to show you some shortcuts and tips using your graphing calculator. And then if you have any questions, just feel free to ask them. You can, none of you are muted. You can unmute yourself if you wanted to ask a question. Or you can go to the chat room and type a question in. So, all right, let's get started. In the chat room, I have posted the access code and dial-in number. Let me type that up here. So, okay. So if you can't hear what I'm saying, just go to the chat and call the dial-in number and the access code that is listed. But I did check myself and everything is working fine. So let's get started. All right, so we're going to start by solving the compound inequality. Okay. So we have 0 is less than or equal to 2x minus 8 over 2 is less than or equal to 6. So we're going to start by multiplying both sides by 2. Ah, what happened?
Jaylene.
Okay. Multiply both sides by 2. That's going to cancel out this 2 here. So we're going to have 2 times 0 is 0 is less than or equal to 2x minus 8, which is less than or equal to 6 times 2, which is 12. Now we're solving for x, so we're going to next add 8 to each side of this compound inequality. So then 0 plus 8 is 8, which is less than or equal to 2x. Negative 8 plus 8 cancels out, which is less than or equal to 12 plus 8 is 20. And then finally, we want to divide by 2 because we're trying to solve for x. And when we do that, we're going to have 8 divided by 2, which is 4, which is less than or equal to x, which is less than or equal to 10. So this is the answer in set notation or set builder notation. Let's look at interval notation. So I like to start with the number line. So I have 4 and 10. So I'm going to do a 4 and 10. So x is between 4 and 10. So we're going to shade in between here. Now, because it's less than or equal to, we're going to use a bracket. And because this is less than or equal to, we're going to use a bracket. Because remember, if it is less than or equal to or greater than or equal to, we're going to use a bracket. If it's just less than or greater than, we use parentheses. Okay, so now here, I like to do the number line because I can then easily, or not easily, but I can visually see the interval better. So you always think left to right. So starting from the left, your interval that we want to include is what I have shaded in black. That's my solution. So we're starting at 4, comma, all the way to 10 with a bracket. So this is our answer here and interval notation. Okay? All right, so remember, if you have any questions, you just ask them as we go along. Okay, number 2, solve the compound inequalities. So we're going to solve them each individually. So we'll start with negative 3x plus 8 is greater than 14. So we're going to start by subtracting 8 on both sides. So I'm going to bring down my negative 3x, which is greater than 14 minus 8 is 6. And then to solve for x, I'm going to divide by negative 3. Now, we're dividing by this negative, so we have to flip that inequality. This is going to become a negative, less than, because of the negative dividing. So we have x is less than 6 divided by negative 3 is negative 2. So that's the first inequality solution. Now we're going to go back up here and do the next one. So to solve for x, we're going to subtract by 1. So we're going to bring down that x is less than 5 minus 1 is 4. And that's the other one. So now we have an OR inequality. So if it's OR, that means that we want to include everything. Everything in the solution. So let's graph it first to see what's going on. So I'm going to use, let's see, we have negative 2 and then we have 4. Let's focus on this one. X is less than negative 2. So since it's less than, we're going to use a parentheses, and all the values less than negative 2 are to the left. So this is this first interval here, like that. Now the next one, x is less than 4. So we're going to use parentheses because it's not equal to, and all the values less than 4 are to the left. So this would be that interval there. Now, for an OR inequality, why do I want to do that? For an OR inequality, we want to include everything. So our solution is not just this part here, it's every single thing we see shaded. So actually, it's all of this is the solution. And so what will we write as an interval? So we always start from left to right. So at the very left is negative infinity. At the very right is positive infinity. So for our solution, we're starting at negative infinity. It starts all the way here. And we always use parentheses for infinity. And it's going all the way to 4. And it's not including 4, so we're going to use parentheses. So this is our solution here. Negative infinity all the way to 4. Okay? All right, let's look at the next one. Solve the absolute value equation. So when you solve an absolute value equation, your goal is to get the absolute value expression by itself first. So before we can start trying to solve for x, we want to get this by itself. So isolate the absolute value first. So in order to do that, we're going to subtract this 18 on the other side of the equal sign. So I'm going to have the absolute value of x plus 3 equals 1 minus 18 is negative 17. Now when you are doing absolute value, remember the definition of absolute value is that it's the distance from that number to 0. And remember, distance is always positive. You can never have a negative distance. So the absolute value of something can never be negative. So that can never equal a negative. But look what we have here, a negative. So what you see here, the absolute value of x plus 3 equals negative 17. This cannot happen because of the definition of the absolute value. So if you see this, if you get the absolute value by itself and it equals a negative number, you can stop right there because it is no solution. That is the answer. You're not going to keep going and trying to solve this because this cannot happen. Now, if this said the absolute value of x plus 3 equals positive 17, then you would definitely continue, write your two equations, and then solve them each. But if it equals a negative, you stop. You cannot have that. That means it's no solution. Okay, so I wanted to be sure and show you an example of that because many people continue to solve this and they get it wrong. They don't understand why it's wrong. All right, let's look at graphing lines and writing equations of lines. So find equations of the line passing through the points, negative 5, 5, and 2, negative 2. So you need two things. You need two basic things to write an equation. Okay. All right. So in those two things, you need a slope and you need a y-intercept. If you have those two things, you can write any equation of a line. Right now we just have 2 points. So we're going to start by finding the slope of this line. So the formula to get the slope of a line given 2 points, we usually refer to the slope as m equals y2 minus y1 divided by x2 minus x1. So what you're doing is you're subtracting your y values and then dividing it by the difference of your x values. So it's helpful to label your points. So this is the first point. I'll call that x1, y1. This is the second point, so I'll call that x2, y2. All right, so now let's plug these values in. Whoa. So y2 is negative 2 minus y1 is 5 divided by x2, which is 2, minus x1, which is negative 5. Okay. So negative 2 minus 5 is negative 7 divided by 2 minus negative 5 is the same thing as adding the opposite. So 2 plus 5, and then negative 7 divided by 7 equals negative 1. So that is the slope. We have the slope now. Now you can either find a y-intercept or you can use point slope form. Okay, so point slope form is the following. Y minus y1 equals m times x minus x1. So m is going to be your slope, and then x1 and y1 is going to be one of your points. So you basically pick one of your points. It doesn't matter. How about we'll pick the ones that are labeled x1 and y1, but you could pick the other point. So x1 and y1. And then you're going to plug in those values into this point slope form, and then we want to write it into slope intercept form, which is y equals mx plus b. Okay. So let's start. So first we're going to go with point slope form. So you have y minus y1, which is 5, equals m, which is negative 1, times x minus x1, which is negative 5.
What are you eating?
That's your m.
What food?
This is your x1. Okay, so x minus negative 5, add the opposite, that becomes x plus 5. That's being multiplied by negative 1, then we have y minus 5 on the left. So now we're going to distribute this negative 1. Negative 1 times x is negative x. Negative 1 times 5 is negative 5. And then we have y minus 5 equals negative x minus 5. And if we want to put it in slope-intercept form, let's get the y by itself. So we're going to add this 5. And then we're going to have y equals negative x. And then negative 5 plus 5 is 0. So you could write this as your answer, or you could just say y equals negative x. And that's going to be the equation of your line.
Listen to me.
I only
Make
have
it a little smaller.
Yeah.
No, the critter.
Maybe see all together.
Yeah.
Yeah.
$10.
Maybe $10.
Okay. But this information here on the right, super important. The two basic things you need to write an equation: the slope and the y-intercept, or use point-slope form. Okay?
And I'm doing the project. So I have so much to do. I'll look
All right.
I'm going to have to be doing this project.
Number 5, find an equation of the line passing through the point 9, 7 and perpendicular to y equals negative 3x minus 4. So what do we need? We need a slope and at least a point. So we can use point-slope form. Okay, so we definitely have the point, but we don't have a slope. But we do have information to help us get the slope. So the slope we're going to get from this info here. So if it's perpendicular to this line's equation, that means that our slope is going to be a negative reciprocal. So remember that perpendicular slopes, let me say opposite, are opposite reciprocals. What does that mean? You change the sign and flip the fraction. Okay? That's what it means to have an opposite reciprocal. All right, so we have this line y equals negative 3x minus 4. So what is the slope of this given line? So the slope of the given equation equals your m, negative 3, which is the same thing as negative 3 over 1. So the slope of the perpendicular equation equals, we have to change the sign, so it's going to be positive, and then flip the fraction. So negative 3 over 1 is going to become positive 1 over 3. So that is the slope we want to use here. And so now we're ready to use point-slope form. So it is y minus y1 equals m times x minus x1. So okay, so x1 and y1 is going to come from your point. That's on the line. And then your slope is going to be the perpendicular slope that we need. So that'll be this guy here. All right. So we're going to have y minus y1, which will be 7, equals m, which is 1/3, times x minus x1, which would be 9. So we're going to distribute 1/3 times x is 1/3 x. 1/3 times -9 is -9/3, which will be -3. So we have y minus 7 equals 1/3 x minus 3. And so now to get y by itself, to put it in slope-intercept form, we're going to add 7 to both sides. So then we're going to have y equals 1/3 x, and then -3 plus 7 is +4. So that's going to be your answer here in slope-intercept form. Y equals 1/3 x plus 4. Okay. For the sake of time, I'm not going to finish this problem all the way, but similar thing except that it's parallel to this equation. Well, first off, this equation doesn't just give you the slope by looking at it. You must write in slope-intercept form to identify the slope. So for this one, we would get y by itself by adding 5x. So then we would have y equals 5x plus 3. Now we can just look at the slope here, which is 5. Now if it's parallel lines have equal slopes. So that means the slope that we would want to use would also be 5. And then you would use the point that they give you, and then use point slope form to find your equation. Okay? So just wanted to kind of go through those steps, but I want to keep going so we can cover as much as possible. Okay, number 7. Find the domain of the function g of x equals 33x over -10x minus 20. Okay, so there's two situations you got to that have special, I guess, rules when you're finding the domain of a function. If you don't have one of these situations, the domain will be all real numbers. But the two scenarios are if you have a variable in the denominator, which we do have here, or if you have a square root or even root. So this has a denominator with a variable. So what you want to do, you want to set the denominator equal, I cannot write, equal to 0. So you want to say -10x minus 20 equals 0. And then next you want to solve for x and exclude that value from the domain. Why is that? Well, remember, if you have a 0 in the denominator, if all of this in the blue ever equals 0, that's going to make this entire function be undefined. So what you want to do is figure out, well, what values would make this entire denominator equal 0, and let's exclude that. We don't want to include that in the domain. So if we solve for x, we'll start by adding 20 to both sides. So we'll bring down that -10x is equal to -20, and then divide by -10, so x equals +2. So we want to exclude x equals 2. So if we look at that on a number line, what would that look like? So let's say we've got a number line, and here's a number 2. And so we have infinity, negative infinity, and then we got 2 in the middle. So the domain is everything on that number line except excluding 2. So we do not want to include 2. So I'm going to use an open circle, but everything else I am including. So everything greater than 2, everything less than 2, but not 2. Okay? So this is what the domain will look like on a graph. Now let's write the domain as an interval notation. So you always start left to right. So starting at the left, we're starting at negative infinity all the way to 2, but we're not including 2, so we're going to use parentheses. And then we have another interval, so we're going to use U for union. And then we're going to start at 2, but don't include 2, so we're going to use parentheses all the way to infinity with parentheses. So this is going to be our answer here. Negative infinity to 2, union 2 to positive infinity. The next question is domain, but it has a square root. So let's look at that. Okay, so you do not, well, cannot, so we cannot have a negative under the square root. That gives you something undefined. It's not a real number. So that means in order to figure out the domain, we want to take what's underneath that radical and set it greater than or equal to 0. Because that can happen. What I have boxed in the red can definitely be 0, and it can definitely be greater than 0, which will make it not negative and make it positive. So let's figure out when this would happen, and that's going to be our domain. So to start solving this, to get x by itself, we're going to add 6 to both sides. So I have positive x is greater than or equal to 6. So this is the domain. That's it. But we want to write it in interval notation. So let's just look at what that looks like on a number line. So x is greater than or equal to 6. So let's see, here's 6. If it's greater than 6, we're going to shade to the right. And if it's greater than or equal to, we're going to use a bracket. And so remember, the very right side of the number line goes to infinity. The very left side goes to negative infinity. We want to write the interval we shaded, so we're starting at the 6 with a bracket and going all the way to infinity with parentheses. So that's going to be your answer in interval notation. Okay, let's solve some systems of equations. All right, so solve the system of equations with an S by the addition or elimination method. And I'm going to tell you, well, I can't say for everybody, but for my students, I really won't know what method they use to solve these, so there's that. And I'll also show you how you can check yourself with your calculator. So addition or elimination means we want to get a variable to cancel out. So we want to create opposites. So let's say I want to get rid of the x terms. if I want to get rid of my x terms, I want to make them be opposites. So right now they're not opposites. This is x, that's 3x. If I add that together, I'm going to just have 4x. But if I multiply the x by negative 3, that's going to make this become negative 3x, which will then cancel out the 3x, and we'll have no more x's. But I have to multiply everything by negative 3. So I'm going to have negative 3 times x, which is negative 3x, negative 3 times y, which is negative 3y, then negative 3 times negative 3, which is positive 9. I'm just going to rewrite the original second equation. And then now I'm going to add those equations. So negative 3x plus 3x cancels out. Negative 3y plus 4y is positive y equals 9 minus 7, which is 2. So y equals 2 is half of your solution. Now to get the other half, we're going to pick one of our equations, plug in y equals 2, and solve for x. I'm going to choose the first equation. So we had x plus y is less than negative 3. So I'm going to take this y equals 2 and plug it in here for y. So x plus 2 equals negative 3. And so I'm going to solve for x by subtracting 2. So x equals negative 3 minus 2 is negative 5. And that is your other half of your solution. So we're going to write that here. So negative 5, 2 is going to be the solution to this system of equations. And what that means is if I were to graph each of these equations, put them in the calculator, or just graph them, not put them in the calculator, just graph them, where they intersect is at the point negative 5 and 2. Okay? Let me show you how you can do that in the calculator. Well, no, let me do the next one first, using the substitution method. Okay, so the substitution method means we have to take one of our equations, solve them for a variable, and then take that expression and plug it into that variable in the other equation. So for this one, we already have an equation that's solved for a variable. So what we're going to do is take 7 over 5x minus 3 over 5, which equals y, and plug it in for y in the other equation. So we're substituting that. So I'm going to have 7x minus 5 times 7 over 5x minus 3 over 5 equals 8. So I took what's in that red box and plug it into y in the other equation. And then I'm going to solve for x. So I have 7x, I'm going to distribute negative 5 times 7 over 5. The 5's cancel, and I'm just going to have negative 7x. And then negative 5 times negative 3 over 5. Those 5's cancel, and I have negative 5 times, well, no, I'm going to have negative times negative 3, which would be positive 3, equals 8. So now 7x minus 7x cancels out to nothing. So I just have 3 equals 8. Now is this true? No, that is not true. So if this ever happens, if your variables go away and you're left with a false statement, that means you have no solution, which means the lines are parallel and they never intersect. Okay? So that would be no solution. If you're doing your test in IMath-AS, they probably want you to type DNE for no solution, does not exist, but they always give you those hints in the instructions to let you know. Okay, let's look at the last one. X minus negative 5y minus 1, and then negative 3x minus 15y equals 3. So now here we're going to solve this, and I'm going to use the substitution method because it's already got the x by itself. So I'm going to take what they have equal to x and plug it into x in the other equation. So I have negative 3 times negative 5y minus 1 minus 15y equals 3. So now we're going to distribute this negative 3. Negative 3 times negative 5y is positive 15y. Negative 3 times negative 1 is positive 3. Then bring down that negative 15y equals 3. So now to combine like terms, 15y minus 15y is 0y. So I just have 3 equals 3. This is a true statement. So that means we have infinitely many solutions. What that also really means is that these two equations are equivalent. Equivalent equations. They are literally the same line. It's like if you graph the first one, then graph the second one, they are the same line. So they are like directly on top of each other. That's why they have infinitely many solutions. Okay? Oh, hold on. I think y'all stopped me. Let's see. Let me check. Okay, so I noticed you guys said negative 2 or positive 20. Whoa, okay. What number, and thank you for stopping me, what number are we talking about? Let's see. Number 7. Whoa, I missed that way from then. Sorry. Okay, let me go back to number 7. Oh, I see. Yeah, right here. Good catch, ladies. Well, I think you're ladies. Judging by your name. Yes, thank you. So when I add 20, I should have added 20 over here. This is a positive 20. And when you divide positive 20 by negative 10, you get negative 2.
Yes.
So this should be a negative 2. And that luckily doesn't change much, but this would be negative, and that would be negative. Thank you, ladies. And are y'all all ladies? Let me keep saying ladies. If there's a gentleman here, then thank you too. But I think it was ladies who caught that. You're a lady. Yay! Okay, thanks, guys. Sorry it took me forever to notice that. I thought I had it where it beeps when you guys type in the chat.
I corrected her.
Yeah.
Let me make sure I had that set. Because if not,
Because she did it wrong.
Yeah.
She accidentally did negative 20 instead of positive.
I thought I had that set. Okay, well, I'll try to be on the lookout for that. But yes, thank you. Good job. That should be negative 2. Good. Awesome. All right. Let me go back. Where was I?
Where was she? I was confused.
Okay. Good deal. All right. This is one we definitely want to do. And I might need more room, so let me...
Oh no. She didn't.
Whoa.
You're not knotted up, baby. I think you're just sore.
Oh no.
Oh, I don't know, but you don't have the knots.
It hurts so.
Okay, I just may need more room for that. Okay, so I'm going to try to talk slow so you can kind of jot this down. I think most of the intermediate algebra teachers do problems like this. I know in my class I definitely do. You'll definitely have one in the final. This is a system of equations with a word problem dealing with interest. So in 1 year, Michael earned $6,300 as a work study in college. He invested part of the money at 9% and the rest at 7%. If he received a total of $493 in interest at the end of the year, how much was invested at 7% and how much was invested at 9%? So just to make sure we understand what we're talking about. So he's going to invest $6,300 in two different accounts. One account you're going to get interest at 9%, and the other account you're going to gain interest at 7%. At the end of the year, he has a total of $493 between the two accounts. And what we want to figure out is how much of that $493 did he get from the 7%, and how much did he invest in the 7%, and how much did he invest in the 9%. So the way that I like to teach these is to set up a table to kind of help organize the information. So first off, remember for interest, we're not going to do that. We're going to have to use the interest formula. Sorry, guys. Okay. So I equals P R T. That is your simple interest formula. So remember, I is for the interest that you earned. P is the principal, or what you invest. R is the rate. And then T is for time in years. Okay, so what we're going to do, we're going to make a table to kind of organize our information. So I have I, P, R, T. I'm going to need more space. I write big. Okay. Alrighty, so I'm going to have we have a 9% interest account and a 7% interest account. That's like your rate. So let's fill in what we know. And then we have a total row. So this first row is for the 9% account. The second row is for the 7% account. And the third row is your total row. So let's look at all of our information. So in 1 year, Michael earned $6,300 as a work study in college. So that's his total amount that he's going to invest. He's investing all of that. So his total investment is the $6,300. So I'm going to put it in my little table. That's the total. Now the question is, how much was invested at 7%? And how much was invested at 9%. So we want to know how much of each of these total to $6,300. So let's make the 9% amount that he invested be X, and the 7% amount that he invested be Y, because that's what we're trying to solve for. That was the question they asked us. Okay, so it says he received a total of $493 in interest. So the total in interest is $493. And then this is all over 1 year. So the time for each of these would be 1 year, 1 year. And now for the rate, when we use it in an equation, we want to always convert the percent to a decimal. So 9% as a decimal is going to be 0.09. 7% of the decimal is going to be 0.07. Now, we need to get two equations to write our system of equations. So the columns, the interest column and the principal column, is going to give us our equations. So we have one column ready to go here. So X plus Y equals 6,300. Which makes sense, right? Because if the total amount that he invested was 6,300, we just don't know how much of that went to the 9% and how much of that went to excuse me, the 7%. But now we need something in this column. Well, remember that interest equals principal times rate times time. So I can get each value here by taking the principal x times 0.09 times 1. So x times 0.09 is 0.09x. And then y times 0.07 is going to be 0.07y. So that's my other equation. 0.09x plus 0.07y equals 493. So now here is my system of equations, and now I'm going to solve it to find the solution to this problem. So I would use substitution, because since I have decimals, that would be kind of awkward and a pain to get opposites by multiplying. So I'm going to use substitution. I'm going to solve the first one for x. So I'll have x equals 6,300 minus y. So I'm going to take this expression and plug it into the other equation. So I have 0.09 times 6,300 minus y plus 0.07y equals 493. And remember, you can use your calculator in this class. So we're going to distribute 0.09 times 6,300. It's going to be 567. Distribute that 0.09 times negative y will be negative 0.09y. Then bring down that plus 0.07y equals 493. Now let's combine like terms. Negative 0.09 plus 0.07 equals negative 0.02y. And I have 567 minus 0.02y equals 493. I'm solving for y, so I'm going to subtract this 567 to the other side so I can start getting the y by itself. So I have negative 0.02y equals 493 minus 567 is negative 74. And then to solve for y, I'm going to divide by negative 0.02. And so negative 74 divided by negative 0.02 is going to give me y equals 3,700. Now I need to get x, so let's go back to my initial x equals equation, and let's plug that in. So if y equals 3,700, I can take that and plug it into the x equals equation. And so I have x equals 6,300 minus 3,700. And so 6,300 minus 3,700 equals 2,600. Now, it's super important that you remember what these values mean. So that's why the table is helpful, or somewhere you want to make sure you wrote down what does x represent and the y represent. So what did x represent? We don't know if it's for 9% or 7%. So x for us was for the 9% account. So when they ask about how much was invested at 9%, that would be that 2,600. And so for the 7%, that would be the 3,700. But it's super important that you pay attention, like you label your variables. Make sure in a word problem you know what your variables represent. Because if you said the opposite, let's say you completely didn't know, forgot, or didn't have written down somewhere if x was for the 9% or the 7%, then you would get the problem wrong. When you did all your work right, you solved it correctly, you just forgot or you didn't remember what the x was for and the y was for. Okay? All right. Okay, long division. She may need more room too. I write big, so that's another thing. Okay, let's see here. All right. This problem is one where there's sometimes like a quicker way to do it, but sometimes for me, quick isn't always best because I can kind of lose. If I skip too many steps, I can kind of lose track of what I'm doing. So you may notice that I'm probably writing more than I technically need to, but that helps me to solve these problems. Okay. All right. So, one sec. All right. So along division, we're going to, the numerator here goes underneath your division box. 4x to the 5th. Notice that it jumps from x to the 5th to x to the 3rd. So we're going to put a 0x to the 4th here as a placeholder. It's going to help us with our long division. Minus x to the 3rd minus 2x squared minus 180x plus 14. And then now for the denominator, that's going to be our divisor. It's going to go out here. So x squared. Again, it skips an x term, so we're going to put plus 0x minus 7. Okay, so when you're dividing using long division, we're going to start with the leading terms. So 4x to the 5th divided by x to the 2nd is going to give me 4x to the 3rd. Or you could think to yourself, x squared times what gives me 4x to the 5th? That would be 4x to the 3rd. So then you're going to multiply. So 4x to the 3rd times x squared is 4x to the 5th. You always want to get the same term first because you want those to cancel out. 4x to the 3rd times 0x is going to be 0x to the 4th. And then 4x to the 3rd times negative 7 is going to be negative 28x to the 3rd. Now we're going to subtract. So when you subtract, you change all the signs basically. So 4x to the 5th minus 4x to the 5th cancels out. 0x to the 4th minus 0x to the 4th is 0x to the 4th. Negative 1 minus negative 29 is the same thing as negative 1. Did I say 29? I meant 28. Negative 1 minus negative 28 is the same thing as negative 1 plus 28, which is 27x to the 3rd. And then we're going to bring down that minus 2x squared. And now we're going to go again. Take the leading terms. X squared times what gives me 0x to the 4th? That would be 0x squared. This is what I mean by this whole step right here is kind of extra because we don't really need it, but to me it helps to write this because, yeah, it just helps. So then we're going to multiply. 0x squared times x squared is 0x to the 4th. 0x squared times 0x is 0x to the 3rd. and 0x squared times negative 7 is 0x squared. Then we subtract. We're going to end up with 27x to the third minus 2x squared, and then bring down the negative 180x. And then I'm going to go again. Leading, I didn't want to do that. Leading terms. So 27x to the third divided by x squared is going to give me 27x. And then we're going to multiply. 27x times x squared is 27x to the third. 27x times 0x is going to be 0x squared. And then 27x times negative 7 is 27 times negative 7 is negative 189x. So now we're going to subtract. So 27x cubed minus 27x cubed cancels out. Negative 2x squared minus 0x squared is still negative 2x squared. And then negative 180 minus negative 189 is the same thing as negative 180 plus 189, which is going to be positive 9x. And then we're going to bring down that plus 14. And then we're going to go again. Take the leading terms and divide them. So negative 2x squared divided by x squared is just negative 2. So I'm going to have negative 2, and then I'm going to multiply. Negative 2 times x squared is negative 2x squared. Negative 2 times 0x is going to be 0x. And then negative 2 times negative 7 is positive 14. And so now we're going to subtract. So negative 2x squared minus negative 2x squared cancels out. 9x minus 0x is still 9x. And then 14 minus 14 is 0. So we have our quotient, which is this here. This is our quotient. And then this is the remainder. And we would write that answer like this. You'd write the quotient, 4x to the third. I'm going to now write, I'm not going to write the 0 term. So 4x to the third plus 27x minus 2. And then we're going to plus the remainder over the divisor, x squared minus 7. So that's your final answer there. So it's just really important that you take your time. And like I said, when you have a missing term, it helps me personally, and I teach this. I write those missing terms, and even if I'm kind of writing extra steps, I write all the steps because it just helps me to follow along with what's actually going on. Okay? I didn't mean to do that. Okay. So let's keep going. Alright, so I'm going to kind of jump around here. We'll definitely factor this. So factor completely. So we have the sum of cubes here. So remember this factor pattern, a cubed plus b cubed. It's going to be a plus b times a squared minus ab plus b squared. So let's look at what we have here. We have 8x cubed and 27. So 8 is the same thing as 2 to the third. So 8x cubed is going to be 2x cubed. Plus 27 is equal to 3 cubed. So that's going to be 3 cubed. So now I have my a and my b. Here is my a, 2x, and my b is 3. So if we follow that factor pattern, a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. If I have 2x cubed plus 3 cubed, I'm going to have 2x plus 3, that's going to be my a plus b, times a squared. So I have 2x, all of that squared, minus a, which is 2x, times b, which is 3, plus b, which is 3 squared. So now we're going to clean this up. 2x plus 3 times 2x squared. That's going to be 2 squared, which is 4, and then x squared, minus 2x times 3 is 6x, and then plus 3 squared, which is 9. So this is going to give us our final answer here. 2x plus 3 times 4x squared minus 6x plus 9. Okay. Add or subtract the rational expressions and simplify. So when you add or subtract rational expressions, you have to have a common denominator. And so here we do not have a common denominator. We have 5x over x plus 1 plus 6 over x minus 1 minus 10 over x squared minus 1. Okay, so to figure out our common denominator, let's make sure we factored all the denominators so we can know what factors we have to work with. So the first two can't factor, but this third one we can factor. This is the difference of two squares. That's the same thing as x minus 1 times x plus 1. Because x squared minus 1 is x squared minus 1 squared, which is x plus 1 times x minus 1. Okay, so we need to have every factor represented in our least common denominator. So we want them all to have the same denominator. So if we were to, let me erase this out the way. If we were to multiply this first rational by x minus 1 at the bottom, then this denominator will be the same as this one. And then if we multiply the bottom by x minus 1, we have to do the top by x minus 1. Same thing for the second one. It already has an x minus 1. It does not have an x plus 1. So I'm going to multiply this bottom one by x plus 1. But I have to do it at the top as well. So now, based on what I just did, the first, second, and third denominators all are x plus 1 times x minus 1. So at the top, I'm going to have x minus 1 times 5x plus 6 times x plus 1 minus 10. And all of that is going to be divided by our common denominator of x minus 1 times x plus 1. So now I need to multiply the top. So I'm going to have 5x times x is 5x squared. 5x times negative 1 is negative 5x. Plus 6 times x is 6x. 6 times 1 is 6 minus 10 over x minus 1, x plus 1. And then I've got 5x squared. Okay. 5x squared. 5x plus 6x is x, 1x. And then 6 minus 10 is negative 4. I need another page. Let me get another page here. Where did that page go? Here we go. Okay, that's going to be over x minus 1 times x plus 1. So now the top part we need to factor. So, and this is, what was this? Negative 5x plus 6x is positive x. All right, so factoring trinomials. Lots of ways to do this. Really depends on how you've been taught or how you have learned. I'm going to use what I call the AC method with slide and divide. Okay, so let's get started. All right, let's do it separate over here. Let's factor 5x squared plus x minus 4. All right, so the way that I factor this, so the leading coefficient is not a 1. It's the 5. So I'm going to take 5 times negative 4, which is negative 20. And I'm going to drop the 5, so I have x squared plus x minus 20. So I got that by doing that times that, AC. Okay, so now I'm going to set up my factors. So I like to use sign rules. So I'm going to drop the first sign and then multiply these two signs together to give me the next one here. It's x squared, so it's going to be x and x. So now I need two numbers that will multiply to give me 20 and subtract, because 20 is negative, to give me this number 1 here. So that would be 5 and 4. 5 times 4 is 20. 5 minus 4 is 1. And if I do it that way, where's my screen going? Okay, if I do it that way, I need to put the bigger factor first. I'm going to put 5 and 4. This also works because 5 times negative 4 is negative 20, and then 5 plus negative 4 is positive 1. Now I'm not done, because remember I multiplied 5 times negative 4 to get the negative 20, so now I got to go back and divide by that 5. You simplify where possible. So like for example here, 5 over 5 is a 1. So I'm going to have x plus 1. And over here, 4 over 5 can't simplify further, so I'm going to slide that up here. So I have 5x minus 4. Okay, I got a question. Oh, hi. I think I have a student joining us. Hello. Okay. So that's how I factor trinomials. And if you're interested, you can email me, jforsythe3 at valenciacollege.edu, and I will email you a link to a YouTube video of a guy, I don't know him, but he teaches this method for factoring as well. It's really helpful. So if you're struggling with factoring, I have some YouTube videos I can refer for you. But I'll have to email it to you. So if you're my student, you can, I've already shared it. But if you're not my student, just send me an email, jforsythe3 at valenciacollege.edu, and I'll send you the videos. Okay, back to the problem. So I'm going to write it down here. So I factored the top, which was x plus 1 times 5x minus 4, and the bottom is x minus 1 times x plus 1. Now that I've factored the top and bottom, I want to cancel any common factors out, which I do have here, x plus 1 times x plus 1. So my final answer is just going to be what's left over, which is 5x minus 4 over x minus 1. That's my final answer there. Okay? All right. So now we're going to solve this rational equation. So to solve the rational equation, we want to multiply the entire equation by the least common denominator. In this case, that's more simple because you only have one denominator here, and that's p. So if we multiply everything by p, we're going to get rid of the fractions and be able to solve it. So we have p times p minus P times 40 over P equals P times 3. So P times P is P squared minus P times 40 over P. The P's cancel. And I just have minus 40 equals P times 3 is 3P. And so now we have a quadratic because we have P squared. So we're going to set it equal to 0. So the best way to do that would be to subtract this 3P on both sides. So I'm going to have P squared minus 3P minus 40. And I wrote it in that order because I want to be able to factor this to solve it. Probably go up here. So I'm going to use my special factor rules again. The leading coefficient is a 1, so that's a little easier to factor. So I'm going to set up my parentheses, equals 0. It's definitely going to be P times P. Now my sign rules are as follows. Bring down the negative, bring down the first sign, and then multiply these two signs together to give me the next sign. So negative times a negative is a positive. So now I need two numbers that will multiply to give me 40 and subtract, because 40 is negative, to give me 3. Multiply to give me 40 and subtract, because 40 is negative, to give me 3. That would be 8 and 5. So we always put the bigger factor first. So we're going to put 8 and 5. And you see negative 8 times 5 is negative 40. Negative 8 plus 5 is negative 3. So now I have my factors. And so now that I have my factors and I'm solving this equation, I'm going to set each factor equal to 0 using the 0 product property. Solve each one, and those are going to be my solutions. So I would add 8 to both sides. So P equals 8. That's one solution. And then I'm going to subtract 5 from both sides. P equals negative 5. That's my other solution. So my two solutions are P equals 8 and then P equals negative 5. And it's helpful also to plug these in to solve and check your answer, not solve them, to check it. So like if we're checking 8, we'd have, if we plug it back in for P, we'd have 8 minus 40 over 8, which is 5. So we have 8 minus 5 equals 3. So that does work. If I check the negative 5, so I have negative 5 minus 40 divided by negative 5. That'll be negative 8. So my negative 5 minus negative 8 will be negative 5 plus 8, which will give us positive 3. So we have our two correct answers. P equals 8 and P equals negative 5. Okay, so now rationalize the denominator. So to oh, what happened? What is going on? Okay. So to rationalize the denominator, we're going to multiply by what's called the I want to move this to the left so it'll be easier. If I can move that over. I don't want to do that. Okay. Okay, so we're going to multiply this by the conjugate. What is that? It's basically, you just change the sign. So it's 4 minus root 7. So we're going to multiply the top and the bottom by the 4 minus root 7. Okay, so at the top, we're going to have negative 27 times 4, and then we're going to have negative 27 times root 7, negative root 7. And then at the bottom, we've got 4 plus root 7 times 4 minus root 7. Okay, so here, negative 27 times 4 is negative 108. Negative times a negative is a positive. And then we have 27 times root 7 over. Now here we're going to FOIL. 4 times 4, 16. 4 times negative root 7 is negative 4 root 7. Root 7 times positive 4 is positive 4 root 7. And then root 7 times negative root 7 is negative root 49. Okay, so we have negative 108 plus 27 over times root 7 over, so in the middle here, negative 4 root 7 plus 4 root 7 cancels out. So I'm just going to have 16 and then minus the square root of 49 is 7. Okay? So now I'm going to have negative 108 plus 27 times root 7 over 16 minus 7 is 9. And then we want to be sure and simplify this. So in order to do that, let's split this up into 2. So we have negative 108 divided by 9 plus 27 root 7 divided by 9. So 108 divided by 9 is 12. So that's going to give me negative 12. And then 27 divided by 9 is 3. So I have 3. And then I have the root 7. So that's going to be my final answer. Negative 12 plus 3 root 7. Okay. I'm going to skip the scientific notation because I'm running out of time. This is a good one. Simplify the complex fraction. Okay, so this is similar to when we solved our, well, I don't want to say that. But you're using a least common denominator here. So you want to do what's called clearing out the fraction. So we have a few denominators. We have the main denominator here, but let's look at this all as smaller fractions. So we have a 6 over 7, a 5 over 3, and then we have x's. So we want to think about the least common multiple, least common denominator between all the denominators that we see. So one way to get a common multiple is to just multiply all the denominators together. It may not be the least common one, but it will be a common one, and you can finish the problem up and simplify it later. In this case, we've got a 7, we've got a 3, so the least common denominator is going to be 7 times 3. So we want to multiply the top and the bottom by that 21. Because by doing that, 21 over 21 is just 1. So when we do this, we're not actually changing the value of it at all. We're just rewriting it in a way where we can simplify it. So I've got 21 times 6 over 7 minus 21 times x over 21 times 5 over 3 plus 21 times x. Okay. So we have 21 times 6 over 7. You could do that as 21 times 6, which is 126, divided by 7, which is 18. Or you could say, oh, 21 over 7 reduces to just 3. So I have 3 times 6, which is 18, minus 21x over 21 times 5 is 105 divided by 3, which is 35. Or you could say 21 over 3 reduces to just 7. So we have 7 times 5, which is 35, plus 21x. And then from here, you check to see if you can factor any more. And if you could factor, which would give you factors to cancel out, you would do that. But in this case, we cannot factor this further. 18 and 21 don't have any common. Well, actually, they do. They do have a common factor of 3. But it's not going to get it further. So if we factor 3 at the top, we have 6 minus 7x. And if we have a common factor at the bottom of 7, we factor that out, we have 5 plus 3x. But as you can see, that doesn't help you cancel anything. So we can actually just stop right here. So we did factor the top and bottom more, but it doesn't result in something that can cancel out. So you don't have to do that. You can just stop with where I boxed in. And that's going to be your final answer. Okay. This one's long. Solving the radical. Definitely want to do this with you. And let me get some extra space here. Okay. All right, so we're going to solve this radical equation. Okay, so to start this off, we want to get one of the square roots by itself, which we do have. So we're going to start by squaring this square root, and if we do that on the left, we must do that on the right. Now, on the left, that's going to cancel out the square root with the square. So I have 41 minus 2x on the left. But on the right, I've got a little bit more going on. We have square root of 9 minus 2x plus 4 times another square root of 9 minus 2x plus 4. So we're going to FOIL that. So we have first root 9 minus 2x. So the square root of something times the square root of that same something just leaves you with what's under the square root. So the square root of 9 minus 2x times the square root of 9 minus 2x is just going to leave you with 9 minus 2x. All right? Now, outer. So I'm going to have plus 4 times 9 square root of 9 minus 2x. Inner, another 4 times root 9 minus 2x. And then last, 4 times 4 is 16. Still have that 41 minus 2x on the left. So let's see here. 9 plus 16 is going to give me 25. So I have 25 minus 2x. We have like terms here, so it's going to be plus 8 square root of 9 minus 2x. I still have that 41 minus 2x on the left. Now my goal here is to get the other square root by itself. So I want to, if I subtract 25, and I have 41 minus 25 is 16. bring down that minus 2x equals minus 2x plus 8 root 9 minus 2x. Negative 2x is going to cancel, and I have 16 equals 8 square root of 9 minus 2x. And I want to get the square root by itself, so I'm going to divide by that 8. So I'm going to have 2 equals the square root of 9 minus 2x. Now that I have this square root by itself, I'm going to square this side. But if I do it on the right, I must do it on the left. So then I'm going to have 2 squared, which is 4, equals 9 minus 2x. And I'm almost done. I'm going to solve for x by subtracting this 9. So we have 4 minus 9 is negative 5, equals negative 2. And then finally, to solve for x, I'm going to divide by negative 2. So x equals negative 5 divided by negative 2, which is equal to positive 5 over 2. And that's your final answer. So let me start from the top just to kind of refresh. So you got to start by getting one of your square roots by itself, which we already started with. So we're squaring that square root on the left to get rid of that radical, but we have to do it on both sides. Notice on the right side, I did not just say, oh, that's this squared plus this squared. No, 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 that's not what that is. It's 2 binomials squared. So we're going to write each binomial twice and then FOIL. And that was all that work on the right, and that eventually led us to that square root being by itself. And then once we get that square root by itself, we square it to get rid of the root. And then we finally solve the equation and get x equals 5 over 2. Let's see, it's freezing. Let's see if it's going to start back. Okay, we're back. Remember, stop me if you have any questions. Okay, perform the operation and simplify. So we have a binomial times a binomial. So we are going to FOIL. Just so you remember what FOIL means, multiply the first term, so 5 times 5 is 25. Then the outer terms, 5 times 11i is 55i. Then the inner terms, negative 11i times 5 is negative 55i. And then the last terms, negative 11i times positive 11i is going to be negative 121i squared. Now, when you're dealing with I, remember, I squared equals negative 1. As soon as you see an I squared, immediately change that to negative 1. So we have 25 plus 55i minus 55i minus 121 times negative 1. So now, see, 55i minus 55i cancels out, and I have 25, and then negative 121 times negative 1 is positive 121. So now I just want to add up 25 plus 121, which will give me 146. This is super important when you're solving or multiplying with I and you end up with I squared. You want to always change that I squared to negative 1. And why is that? So remember, the square root of negative 1 equals I, right? And so if we were to square the square root, we would do it to both sides. So squaring this square root cancels the root, and I'm left with negative 1 equals I squared. So that's why I squared equals negative 1. Okay? All right. So 22. So a rectangle is drawn, so the width is 6 inches longer than the height. So let me just draw that. So the width is 9, I said 6 and it says 9. Wow, okay. It is 9 inches longer than the height. So when you're solving a word problem, it's okay, so we're saying that this width is 9 inches longer than something else. We'll make that something else be the variable x. So up here I'm going to write down x represents the height. Or you may write h so you know that represents the height. Either way, make sure you know what your variable represents when you're doing a word problem. So the width is 9 inches longer than the height. So if this is 9 plus x, that means that the height has to be x. If the diagonal's measurement is 45 inches, so that is from here to here, is 45 inches, find the height. So we're going to use Pythagorean theorem. And that is a squared plus b squared equals c squared. And if you have a right triangle, your a and b will be your legs, and c is always your hypotenuse. I'm going to need some room for this one, so let me do that. Why do I want to do that? Okay. All right. So, 1 second. Okay, so in this case, I'm going to say this is the same as A. This is the same as B. So I'm going to say nine plus x squared plus x squared equals 45 squared. So 9 plus x squared is going to be 9 plus x times 9 plus x squared equals 45 squared, which is 2025. So I'm going to have 9 times 9 is 81 plus 9x plus 9x plus x squared plus this extra x squared equals 2025. So I have 81 plus 18x plus 2x squared equals 2025. Okay. Now I'm going to subtract 2025 to set it equal to 0, so I can then solve this. This should be plus. Okay. All right, 81 minus 2025 is going to be negative 1944 plus 18x plus 2x squared equals 0. So now I'm going to factor. I'm going to write this in standard form, so I'm going to write 2x squared plus 18x minus 1944 equals 0. I'm going to factor out a 2. Yeah, factor out a 2. So I have x squared plus 9x, and then 1944 divided by 2 is negative 972 equals 0. So that's going to be really hard to factor. So I'm going to introduce the quadratic formula. I have a question. 1 second. Okay, so it said, how do I know when to use that formula? Good question. So the question was asked, when do we use a formula? I'm assuming he meant the Pythagorean theorem. Good question. So the Pythagorean theorem is used when you have a right triangle. And since this was a rectangle, that tells you that this is a right angle. And so it gave you these dimensions here, the width and the height, and they said the diagonal measurement is 45 inches. And the diagonal is from one vertex to the other in a rectangle. So you essentially have a right triangle here. And so because you have a right triangle, you can always use Pythagorean theorem to solve for any missing side or any side length in a right triangle. All right? Okay. So I hope that answered your question. Alrighty, so what I'm going to do now is I'm going to use the quadratic formula to solve this, because I'm not going to think of factors of 972. That's kind of crazy. So the quadratic formula is used to solve any quadratic that is any quadratic really, it doesn't have to be factorable, but any quadratic. So I'm going to use it for this part here. So it's x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So what is your a, b, and c? It's coming from your standard form of the quadratic, ax squared plus bx plus c. So in this case, a would equal 1, b would equal 9, and c would equal negative 972. So we have x equals negative 9 excuse me, plus or minus the square root of b squared, which is 9 squared, minus 4 times 1 times negative 972, all divided by 2 times 1. So we have x equals negative 9 plus or minus the square root of 81, negative 4 times 1 times negative 972 is positive, excuse me, come on, computer. Don't die on me now. There we go. Positive 15,552. All of that divided by 2. So now 81 plus 15,552 is going to be 15,633 over 21. So now we're going to take the square root of 15,633. Oh no, that gives me a... Okay, so it's to round. Okay. That's going to give me... Actually, let's do it at one time. 1 second. Let me check something. Oh, I said 21, not 21. Wow, okay. Going too fast here. This should be 2, not 21. Okay, this might be better. Okay. Something is weird with this. I'm doing something off. Let me check my work. Something is off with what I'm doing. Ah, what's happening? Hold on 1 second. I think something is weird with my work. Okay. Let me check my work really quick here. 9 plus x squared 81 plus 9x plus x squared equals that. Okay, 81 plus let me try something. Negative b plus the square root b squared minus 4 times a times Whoa. Something's wrong with this problem, because my answer is not the answer. Let me see. Minus square root squared minus 4a c Yeah, something is weird with my answer. Okay. Something is off with this question. I don't quite know what it is, but I don't want to waste any more time. So I don't know. I think I may have typed a number wrong when I typed this up. I apologize. But something's weird with this question that I typed. So the main thing with this one, though, to keep in mind, and this may be a problem that's not on this final, but do know that the right triangle, you can always use Pythagorean theorem to find the missing sides. But I think I may have put the wrong number there, which stinks. But let me move on. So I apologize for not having an answer for 22. The answer on my answer key is 27, but I don't have the question that goes with the answer key. I know, it was poor planning. So if you got 27, that would have been the answer, but I don't want to dwell longer, so I want to keep going because I only have about 8 minutes. Oh, okay. Let's do some word problems. Okay, let's do 26, which is another word problem. So a rectangular garden is 20 feet longer than it is wide. So let me do my rectangular garden. So it's 20 feet longer than it is wide. Its area is 30 feet squared. So the area of a rectangle is length times width. So we're going to say 20 plus x times x equals 300. So we're going to distribute. So we have 20x plus x squared equals 300. And then whenever you're solving a quadratic, you want to set it equal to 0. So we're going to subtract this 300. So we'll have x squared plus 20x minus 300 equals 0. And then from there we would factor. So we need to set this up. We need x times x. Let's bring down the first sign and then multiply the signs together to get the next sign. So we need two numbers that will multiply to give me 300, but subtract because 300 is negative to give me 20. That'll be 30 and 10. And I want to write the bigger factor first. And then to solve this, I want to take each factor, set it equal to 0, and solve. So x equals negative 30, x equals positive 10. Now we're talking about an actual rectangular garden, right? So can you have a negative dimension? No, you cannot. So we're going to reject this x equals negative 30, because if you, like, let's just say the problem started off here, and this was not a problem that had any context, it wasn't talking about any real life situation, then sure, you'd have two solutions, x equals negative 30 and x equals 10. But these values came from a real world problem, so we don't want to include the negative answer. You can't have a negative dimension, so we're only going to accept this x equals 10, and that's going to give me my information to answer the question. So if x equals 10, that means that the width would be 10, and the length would be 20 plus 10, which is 30. So it would be 30 and 10. All right, let's talk parabolas. So you may have to match up a graph with a parabolas equation or so forth. Something to keep in mind. Let me write something out in vertex form. So y equals a times x minus h squared plus k. So the a tells you whether the parabola opens up or down. So if a is greater than 0, it opens up. If a is less than 0, it opens down. So in this case, y equals 5 times x plus 2 squared minus 1. This parabola would open up. All right. What is the vertex? So when you are given a parabola in vertex form, that's what this is. You can very easily just look at it and identify the vertex. The vertex is h, comma, k. But it's super important to pay attention that the sign that you see here is going to change when you write it in the vertex. And I like to say change the h, keep the k. So for example, in this case, it's x plus 2 in the parentheses. So for your vertex, negative 2 would be the x coordinate, change the h, which means change the sign, and then k, keep the k, so the y coordinate would be the same, negative 1. Change the h, keep the k. That only works for vertex form. Let's look at if it's not in vertex form, so like 28, example here. F of x, or it may say y, f of x equals y, same thing, equals negative x squared minus 12x plus 6. So let's skip to b for right now. So to find the vertex when the equation is in standard form, we're going to find the x coordinate, which would be negative b over 2a. So you first want to identify which your a, b, and c would be. So remember, we're getting that from f of x equals ax squared plus bx plus c. So in this case, a equals negative 1, b equals negative 12, and c equals 6. So for this problem, to get the vertex, we're going to get the x-coordinate of the vertex by plugging in b and a. So in this case, that would be negative times negative 12 over 2 times negative 1. So negative times a negative 12 is a positive 12 over negative 2, which is negative 6. So that's the x-coordinate of your vertex. So it's negative 6 comma something else. So to get the something else, we're going to find f of negative 6. We're going to plug in that negative 6 into your function to get the y-coordinate. So that's going to be negative times negative 6 squared minus 12 times negative 6 plus 6. So follow your order of operations. So parentheses. Within the parentheses, if you can simplify, you do that. In this case, we can't do anything in the parentheses. The next step is exponents. So the exponent is here. What's the base for this exponent? This negative 6. So negative 6 squared is negative 6 times negative 6, which is positive 36. We still have this negative out here. Minus 12 times negative 6 plus 6. Next is any multiplication or division. So we have negative 12 times negative 6, which is positive 72. So I have negative 36 plus 72 plus 6. So negative 36 plus 72 plus 6 equals 42. So the vertex for this parabola is negative 6, 42. Let me show you some tricks with the graphing calculator where I have like a minute or two left. You can use a graphing calculator on your final in intermediate algebra. So I hope you have one. If not, the depot has some you can check out, the library, the math lab in building 1. All right, so let's play around with this. So if I turn this on, let me turn it on. Okay, so if I want to graph any equation, I have to go to y equals, which is here. So in order to use this, you have to make sure it's set equal to y or set equal to f of x, which this equation is set up like that. So I'm going to put this equation in here. So this is negative. This is where you're going to do your x squared minus 12x plus 6. This can actually tell you a lot of useful information. So let's first graph, let's say zoom. We want to make it to where we can see what we're talking about. So say zoom fit, because it may be a graph that's beyond the standard window. Press enter. So you can kind of see a part of your parabola here. So it may be helpful to zoom out so you can see what's going on over here. So let's zoom out. Press enter. All right, so that's it there. Okay, so find the value, let's say the vertex. How could I get the vertex here? So the vertex of this parabola that's facing down is going to be your maximum. So you can calculate a lot with this. So we want to calculate something that's in yellow, so we're going to say second trace. So we want to get the maximum. So if we go down to this option here, maximum, and press enter, you want to basically set your boundary. So here is the number here, but you don't know exactly, you can't trace it exactly. I mean, it could be any number of these. We don't know. So it's saying left bound. So just put your boundary on the left side of the vertex, which is somewhere over here, and press enter. You see how I like set a little boundary here? And now you want to mark the right side of it. Doesn't matter where you are, as long as you're on the right side of it. Press enter. Now you want me to guess, and you say yes I do, and you press enter. And then now it is going to calculate the maximum. All right? So it's super duper specific, but x equals negative 6, y equals 42. All right, and that's what we got, right? Negative 6, 42. That's your maximum. If it asks for your y-intercept, that just means you plug in 0 for x, which is really simple for these because it'll just be 0 plus 6, which would equal 6. And then find two values of x that make f of x equal 0. That would be for D where your function crosses the x-axis, right? So the way you would do that, that would be these two values here. So you can second calculate. Those are called zeros. So you would choose that, and then again you want to kind of establish the left boundary because you have two zeros. So if I say, okay, that's the left side of that 0, this is the right side, I want to calculate, and then there's one value here where f of x equals 0. X equals, it says round 2 decimal places, so you would say x equals negative 12 plus 48. And then you can get the other one by saying second, calculate, 0. And I want to say, okay, this is the left side of it. Here is the right side of it. Press enter, and then there's your other 0. X equals 0.48, comma 0. Okay, I ran out of time, but hopefully this was helpful. Please, if you have not gone to the Learning Support YouTube channel for Osceola Campus, it has tons of videos that you can access. And matter of fact, let me see if I can pull it up really fast, because there's a lot of helpful resources there. Okay. Okay, so what you can do, if you type in Osceola Learning Support and you select this channel here, Learning Support Virtual, with this little icon, there are 959 videos on here. Okay, and so you can actually search. These are tutors here in the Math Depot. So there are tons of videos here that range from developmental all the way to calculus. So if you go to, let's see, playlists, they have playlists by Professor Ponciano. I believe this is for developmental, but there are final exam reviews for a lot of classes. They have chapter reviews. These chapter reviews are also in your Canvas course. And then if you want to look at just general videos on certain topics, you can search. It would probably be better. So there's videos here on certain topics, or you can search them here. So let's say you want to watch some stuff on rational equations or something. If you type rational, you will see, a rational equation application, solving rational and literal equations, adding rational expressions, so many things. And this is from our tutors here in the depot. So definitely come to the depot to get tutoring if you would like. We will be here open during final exam week, but also take advantage of this website that's brought to you by the depot staff, and then also Smart Thinking. So with that, if there's no other questions, thank y'all so much for joining me today for this review. And I will email everybody who signed in today a recording of this video, and I will see you around. Happy studying.